And we're live! Welcome to RockSim Live. I am Tim Van Milligan. I'm the host here today. It is August 1st. We're already into August. Wow, 8th month of the year. Welcome again. This is where we talk about RockSim, RockSim Pro, and the Launch Visualizer, and how you can design better rockets. So I have the chat going, and I've got a monitor here. And so if you have a question about RockSim Pro, or the Launch Visualizer, go ahead and put it in the chat. That's what we're going to talk about today, is what you want to talk about. And you can also say hello, and I can recognize you. And there's already a few people in the room. We have Chris's Rocketry and More from Golden Valley, Arizona, and Curtis Howe from Portland, Michigan. So welcome, everybody. Yeah, it's been a busy week. As most of you know, that I'll be going to the World Space Modeling Championships later this month. Now we're like days away. We can almost count them on our fingers. And I've been trying to get ready, trying to get everything ready. So when I'm gone, everything here is, you won't even notice that I'm gone, except for me not being here at RockSim Live. I've been doing a lot of videos and newsletters. I need to do one more video. You know, we do every week. We do, and we call it the advanced construction video. And it's a how-to video. So how to do something in rocketry. So you know how to make your experience better. And I need one more topic. That's the hardest part about doing these videos, is just coming up with something new and different to talk about. So if you've got a burning question on how to build something, you know, something that I can videotape, go ahead and put that in the chat too. I'm looking for topics, and hopefully you'll come up with some great ones. Yeah, so that's what I've been doing this week. And I'll be doing it next week as well, trying to get ready. I'm getting close. I got to do that one video, like I said, and then I got to do one and a half more newsletters. And the last newsletter is already written, so I just have to do the layout and the production, getting it ready to go. So I'm getting close, and I'm really happy about that. So let me share you my screen. So if you are brand new to the channel, this is where we talk about RockSim. Where you get RockSim, which is our software. RockSim is a design and simulation software. And you get it at apogeerockets.com. And there's this scrolling banner bar here. And so if you find the one right there, RockSim 11, that's our latest version of RockSim. And you can download it. You can buy it. You can download a free demo. There's a 30-day free trial. And then there's the Launch Visualizer. So the Launch Visualizer is doing your simulations in the cloud. So you don't need to install any software on your computer. The downside is that you can't design a rocket. You can only simulate them. So you need RockSim to create the design, or you need to download designs that somebody else has already made. And if you go to the Apogee website, we try to do almost all of our rockets have a RockSim file. So you can just download it and run it in the Launch Visualizer. And then you can choose your engines, choose your launch angles, choose where on the planet you want to launch from, which is really cool. So you can see what obstacles you're going to be dealing with when you go to launch your rocket. Yeah, so that's what RockSim Launch Visualizer is. And then RockSim Pro is our 6 degrees of freedom version of RockSim. So it's like RockSim on steroids. So you can do a lot more stuff, and you get the same three-dimensional visualization that you get in the Launch Visualizer. So that's the difference. So you get all that here at apogeerockets.com. If you go to the How To and Guide menu button right up here, and then come down here to Software, this is where you can download the free trial. Our video tutorials. Now, this is the video tutorials here are, you know, if you're just getting brand new and just starting out in rocketry or in RockSim, how to use it. And there's videos like the very basic stuff, and then we progressively get into harder and harder stuff, or not harder, it's just more complex designs, and and digging deep into the software and what it can really do. All that is in there. And what we do here in RockSim Live is then we take specific questions on how to do something. And it can save you a lot of time rather than watching those videos. So you can just ask your question and I'll answer it. Also on this page, there will be frequently asked questions, the system requirements and the version history, what's been updated, things like that. So that's what you see. So we got our first question from Wheelock's World. It says, let's see how fast you can design a complete rocket in RockSim. All right, I'll take that challenge. Okay, so starting a new design. So now we're in RockSim. This is RockSim. What you see here is I have already design loaded, and this is the Mako. So to start a new design, you come up here to the New button. You just click that. And it'll ask you if you want to save your old design, and I'm going to say no. All right, so to design a rocket, we kind of go across these tabs. So the first tab is the rocket design attributes. So we need to give it a name. So Wheelock's Rocket. And then all the other stuff, I'll just leave it as the default. So that looks good, and then you go to the next tab in the rocket design. So in this one we have to select the nose cone because we're going to start working from the top down. When you do that, it opens the database of all the nose cones that are currently in the database. So I'm going to pick a nose cone. This is the hardest part, is deciding what size rocket I'm going to make. PNC 66. So that's a 66 millimeter, which has a diameter of 2.6 inches, has a length of 9 inches, and we'll click OK. So there's our nose cone, and I'll just leave everything. Since we're doing a speed test, we're just going to leave all the defaults as like they are. That's the next best thing. So the next thing under a nose cone, we need a body tube. So here is a body tube. And we selected a 66 millimeter, so we're going to look for 66 millimeter. All right, so there's a 18-inch long 66 millimeter. I'll click OK. And there's a tube. And now I could leave the defaults, but this is going to be like a fairly short, stubby rocket. You can't see my hands. But it's 18 inches long here, plus another 9 inches. So we're at a total of 27 inches long. So I want something a little bit longer. So I'm going to adjust the length. And I'm going to make it so my total rocket is about 36 inches long. So I'm just taking the slider bar, looking at this number here for the length of the rocket. And 35, there we go, 36 inches long. So we make that 27 inches, hit the tab. All right, so now we have a nose cone and a tube, and there we go. So next is we need either the motor mount or the fins. So let's start with the motor mount. So let's make this a 29 millimeter diameter motor mount. So to make the motor mount, you select the body tube, come over here to inside tube, because the motor mount is an inside tube inside this outside tube. So click on that. And now we're looking for a 29 millimeter motor mount. So I'm going to select this 29 millimeter and I'm going to click OK. Now this one's pretty long. So it's 34 inches long. So this one I'm going to shorten up. So I'm just going to shorten it up to maybe like 7 inches, somewhere in there. All right, so there's my 7-inch tube, and then I need to move it to the back of the rocket. So I'm going to change the reference location from the front of the part. The owning part is the tube, since it's inside the tube. So I'm going to make it reference from the base of the owning part instead of the front. So right now it changed. The only thing that changed with this location right here. Before it was 0, now it's 20 inches. And if I make it 0 again, it will be flush with the back of the tube. Hit tab, and it's now at the back of the tube. Now I want it to stick out a little bit because for me, I want to either put a retainer on there or some masking tape. So I'm going to make it a negative 0.5 inches. So then it will hang out the back a 1/2 inch. Now I do need to specify this as a motor mount. And it tells me that this is a motor mount right here. This is important to check that and then just confirm the diameter as 29 millimeters. And everything, it looks fine. So I'm going to hit OK, except for I'm going to change the name to motor mount tube and click OK. All right, so now we have a tube, and now we need some centering rings in here. So I'm going to click back up here to this body tube and then look for centering ring. So here's my centering ring button. Click on that. And I'm going to cancel out of the database. Now, I could look for a 29 to a 66 millimeter. How come I can't grab? There we go. 29 to 66. Here's a 2966 plywood. I could do that, which will work. Or I can just let RockSim design it for me. And I'll let RockSim design it for me. So I'm going to check this box that says automatically calculate the known values. And when you do that, RockSim will fill in the outside diameter, inside diameter for us. All I need to do is select the thickness, 0.125 inches. You can see my ring right now is right here. And when I slide it back in the rocket, as soon as I get it over the motor mount tube, you'll see the inside diameter change. So right now, just kind of watch it, and there. Did you see that? Now it automatically found the inside diameter for us. And I'm going to change it from the base of the owning part just because we did the same thing back here. By changing it to the base of the owning part, if I ever change the length of this tube, this position will always stay fixed from the back of the tube instead of being measured from the front of the tube. And that's important. Like I said, if you change that length of the tube, if you make it longer, that ring will travel with the back of the tube instead of being fixed from the front of the tube. I'm going to click OK. So we have one centering ring there. We need to add one more back here. So what I'm going to do, oops, I didn't want to do that. Cancel. Save and changes. Cancel now. What goes on? Cancel. No. I'm going to do a copy and paste. So I'm going to select this ring and then go up here to copy and then go to the body tube and then go to edit and then paste. Didn't work. Copy, edit, paste. Still didn't work. Let's do a right click, copy, and paste. That worked. Okay, so we got a second centering ring, but it's on top of the first ring. So now we just need to adjust the position. Adjust the position. Not adjust a position. So double click on that. And so here's the ring, and we're going to change the location. We're just going to slide it. Oop, we're measuring from the base of the part. So we got to move it towards the base. And that's a good position right there. And I'm going to change the name. I'm going to call it aft centering ring. So we can tell it apart from the forward one. We also will need a parachute and a shock cord in here. So let's do that first. So I'm going to get, so a parachute, come over here to parachute, add the parachute. Again, it looks in the database and you can, why won't it let me grab that edge? There we go. My mouse hot point is kind of weird. Okay, so I think a 30-inch nylon octagon chute might work. We can always adjust that later, but that's a good size chute. So there's the parachute. And I'm going to change the location. I'm going to move it below the shoulder of the nose cone. And that's the location here. So now this one I'm going to leave the reference point from the front of the owning part. And if I make the tube longer, it will always stay in this position. And we'll click OK. All right, so now we got a parachute. We need a shock cord. And a shock cord, you don't see a shock cord button, but it will be a mass object. So a mass object is anything in the rocket, inside the rocket, that doesn't have a defined shape, like clay, nose weight, or an engine hook. A shock cord is definitely something that doesn't have a defined shape. Again, it looks in the database, and I'm going to cancel out of that. I'm going to go up here to classification and say that this is a shock cord. And I'm going to change the name to shock cord instead of mass. And I need to specify a material. And I'm looking for like 300-pound Kevlar, which is typical for this size rocket. And I need to change the length of that shock cord. And the shock cord, I typically make like 5 to 10 times the length of this. Let's make this, change this to feet. So we got 3 times 10. 30 feet would be too long. 15 feet would be about right. So that's about 5 times the length of the rocket. And then the location, right now the location is right here, is that circle. And I'm just going to move it back below the nose cone, or the parachute right there. And then click OK. So now we have a shock cord. All right, so now we just need fins. And oh, maybe a launch lug. So let me put the launch. We'll put the launch lug on later. Let's put the fins on. So select the body tube, and now we have a choice of fins. We can do regular fins, custom fins, which have a curved edge, and then a ringtail or a tube fin. So I'm going to do custom fins. All right. And so again, it looks in the database, and I'm going to exit out of that, and it puts a generic fin on the rocket. And it gives me a fin count of 3. If we want to change the shape of these fins, since this is right now this would be just a regular fin, but if we wanted to change the points and what it looked like, we would come here to this screen, which is the plan points. And then I can start grabbing a point and moving it around. And then you can see what that shape was going to look like when I do that. Yeah, that's a cool shape. It looks about right. What we're looking for, though, to make sure it's right, is the distance between the center of gravity and the center of pressure. Here's the center of pressure here, this red dot. Here's the center of gravity. We need to make sure that that center of gravity is forward of the center of pressure, which it is. There's one more thing. Once we put the motor in, that center of gravity is going to move back. So we may not be finalized on our fin shape yet or the fin size, but we can always come back there. Let's say we want to make this a through-the-wall fin. So to do that, you click on the through-the-wall mount, fin mount right here. And the first thing you do is always hit this button, say calculate the fin depth. And the fin depth is the distance between the inside diameter of the tube and the outside diameter of the motor mount tube. And if you click that button, RockSim automatically calculates it, and it calculated at 0.6950 inches. The tab offset is the distance the tab on the fin starts from the leading edge point right here. So if you started at 0, it's going to go straight down. And then you need a length, so how long the tab is inside the tube. And I'm just going to grab the slider bar and I'll show you how that works. So you can see that tab growing. Now if I move the tab offset, you'll see that the front is moving. And let me zoom in here. So to zoom, I'm using my mouse. I'm just using the scroll wheel on the mouse. You can also use the buttons over here to zoom in. And then to move the image, you just click and drag. So that actually looks like a pretty good fin tab. So I'm happy with that. Do I want to make this a 3-fin or 4-fin rocket? Let's see. Let's go 4 fins. Let's see what that looks like. That looks pretty good. If you want to see from the back of the rocket, you come over here to the view. And let's just look at it from the back. Looks pretty normal. So let's say that's good. Then click. We have to select the material. So right now, I think I'm going to make these out of basswood. And the fin shape right now, it's got a square leading edge. You can tell by looking at it in 3 dimensions. And I didn't select the colors because I must have had this color selected previously. But I don't mind this color at all. Okay, so here you can see we got a square edge on that fin. If I change the cross section to rounded, you see that the edge is rounded off. I can make it airfoiled. Airfoiling on custom fins is a little bit harder because RockSim has to try to figure out what the airfoil looks like. Let's just leave it rounded. It looks better. In the back, we got our motor mount tube, which everything looks okay. My fins are hanging off the back of the rocket just a little bit because we rounded the edge, but that's okay. We'll leave it. It's not going to hurt anything. All right, so we got our fin made. Let's put a rocket motor in it. So to put a rocket motor, you click on Prepare for Launch. That's this button right here. Come down here to choose an engine. Now this is a 29 millimeter, so right now we're only showing the engines that match the motor mount diameter. So we selected 29 millimeters as our tube size, so it's only showing the 29 millimeter motors that are going to fit in here. So let's do an F27 red line, and I'll select an engine delay. I don't know which to choose, so right now I always start with the longest one, and then the overhang, I'm going to make it a 1/4 of an inch. We'll put a retainer on this to lock it in place. And usually they stick out a 1/4 of an inch, which is kind of like that stop on the back of the motor. And click OK. And if you look here in the 2D, you see the motor has been added. Under flight events, we have a parachute. We'll say maximum ejection delay. And we'll click OK for now. We're almost ready to launch. All I need to do is put a launch lug on here. And the reason I put the motor in is because I wanted to know where the center of gravity is going to be. So before it was a little bit forward. Once we put that motor in, it shifted back a little bit. And then our launch lug, the position of the launch lug is usually want it to span. If you're only doing a single lug, you want it to span the diameter. If you have 2 lugs, you'd put one up the front, one at the back. Again, they span that center of gravity. So click on the body tube up here, and we're going to say launch lug. Cancel out of the database. Make this bigger so you can see it. Why can't I grab this mouse? Doesn't want to work. Okay, so let's go to the database and select a 1/4 inch launch lug. So you click on the database button, then choose from the database. And I'm looking for a 1/4 inch launch lug. Here's a 1/4 inch by 3 inches long. And it placed it on the rocket somewhere, but it's hidden. There it is. Let's go back to 2 dimensions. So there's our launch lug. And so I want to slide that location back here. So I'm going to go to the General tab, which has the location, and then just grab that slider and move it back so that it spans across that center of gravity. So that looks good right there. The other thing is if you look at it from the back of the rocket, it's interfering with one of the fins. So we need to move it off to the side. And to do that, you'll go over here to the Radial Position tab. And you can grab this little slider wheel and move it around to where you want it. Or you can type in a value right here, and I'm going to type in 45 degrees. So it puts it right in the middle of these two fins. So we're looking at the back of the fins. It's got a rounded edge here, and this part on the inside is the through the wall fin tab. All right, the rocket is designed, so we're going to click OK. All right, so that took us 20, well, I don't know when I started, but it's 25 minutes after the hour right now. And I've been talking a lot and telling you why I was doing things, certain things. So I could design this faster than that 25 minutes, but I didn't want to lose anybody along the way, so I stretched it out a little bit. So Terry, 25 minutes at max. Let's launch it. So we're going to go to prepare for launch. The flight events, the parachute, we have set at maximum ejection delay, which is typically the default. Simulation controls, just leave it at default. Starting state, we got a 60-inch launch guide, so that's the length of the launch rod. And the launch angle is straight up. Launch conditions, we're at an altitude of 700 feet. And let's give it some wind. Let's do a custom speed range of 8 miles an hour. And this is going to be a constant 8 miles an hour. So for that, you have to set the low and the high wind speed at the same value. And that gives you a constant wind blowing across your launch field. Leave the thermals alone, and that makes it so that this whole column is ignored. And then competition settings, we're going to ignore that too. And then we're just going to hit flight profile. I must save our design. Okay, so it's going to ask us to save. I'm going to put this on my desktop, and I'm going to call it Wheelox Rocket. And hit save, and it's running the simulation, and it's got the results, and the results are back. With that Aerotech motor, we want 1,170 feet. And so what we're seeing on this screen right here is a trajectory of the rocket, because altitude is just one piece of how the rocket flew. We also want to see where it's going. So we're going to launch it with this button. You can see it kind of wiggled off the pad. It's arcing a little bit. You can tell there's wind because this is the smoke, and the smoke is drifting across the field. All right, the rocket arced over, and the parachute came out, and now it's starting to descend to the ground. And this is going to be in the air quite a long time, so I'm going to take the time slider here, and I'm just going to grab it and slide it all the way to the end. So it landed 607 feet downrange. The trajectory looks pretty good. We see these lines right here. These are the weathercocking lines, and it tells us, is the rocket going more up than sideways? And as long as the peak point, the apogee point of the flight, is inside this cone, it's a good flight. And so that's fine. We're looking at where the parachute came out, which is right here. You can tell that because we can tell its descent right here because it's a nice straight line. The only question is, at what speed did the parachute come out? I like to see my speed be under 50 miles an hour when the parachute comes out. I can't tell that from this screen, but I can tell it by looking at this summary screen right here. So we have optimal delay of 5.82 seconds, and the delay we selected was 8 seconds. So we're a little short, or a little long on the delay. And I want to see velocity at parachute deployment. So to get that value, right click on this header bar right here, and then choose Organize Columns, and it will bring up all the things that you can display in this chart. And what I'm looking for is velocity at chute deployment. Where am I? I'm missing it. It's got to be in here. Oh, velocity at deployment. Oh, it's already showing it right there. All right, so there it is. I said I want to be under 50 miles an hour, and we're pretty close. So I would not fly this rocket. This rocket is okay the way it is for these conditions. I would, like I said, the optimal delay would be about 5.8 seconds. So anywhere between 5 and 6. The recommended delay is 4. This is going to be an early deployment. Let's try with a 4-second delay. So again, to go prepare for launch, go to the ejection delay, and select the 4. And let's look at the flight profile again. All right, so I just peeked under here to see the final results. So with a 4-second delay, the rocket went 1,124 feet, and we still have a high deployment. So how come these numbers are so close? Well, the first one, if we look at this parachute right here, you'll see an arrow, and the arrow is pointing downwards, which means that the rocket was coming down when the parachute opened. This other one, the rocket was going up when the parachute opened. So it never really reached its peak altitude. So let's see that. So it's launching, it's coasting right now. 1, 2, 3, 4 seconds, pop. You can see that, you know, it popped. It still had some velocity. It could have gone a little bit higher. So it opened going on the way up, but it was still moving pretty fast. So of the two choices that we have, I would choose, if it's a windy day, if the winds are going to be greater than 8 miles an hour, excuse me. If it's going to be greater than 8 miles an hour, choose the short delay because the rocket's going to weathercock more. And if it's a calmer day, the winds are less than 8 miles an hour, then use the longer delay. You still want to watch it that it doesn't weathercock. That's the only thing that I'd be concerned about. All right, so we've designed a rocket and ran 2 simulations, and we've learned a lot about this rocket. Now this is your basic design. Now we can go and enhance it in a number of ways. We can change the colors, we could add decals, we could change the shape of our fins, we can put more parts into it. But this is, you know, your basic, how fast can you design a rocket? It's pretty good. All right. And Wheelox World says, you are building a rocket with discussion, which is impressive. Well, thank you. I thought so too. David H. says, will there ever be pictures added to the database to aid in choosing? Probably. That's a good question. I never thought about that idea. Theoretically, yes, it could happen. I'm just thinking through the logistics of it. So, like, what he's saying is, like, when you go to design a rocket and you go to the database, so I'm going to the fin database and I go choose from database. And what I have here is just a chart of fins. And I have no idea what these fins look like. And so what David is asking is, can you put some kind of little icon over here to show the shape of that fin? For fins and nose cones, that's where you want to see, because those can be radically different. A tube, yeah, it's always going to look like a tube. A centering ring, it's always going to look like a centering ring. But fins and nose cones and maybe transitions, that would be nice to have a picture. So could a picture be added? The answer is yes, it could be added. The downside is that it's going to make the database storage bigger, because then we have to store images of all those items. That would probably be the fastest way to do it. I don't know. Let me think about that one a while. That's good. That's a good observation there. Wheelock World says, RockSim is so awesome. Thank you. Rick DeFossa says, when a motor burns, the mass goes down, so the CG moves. I know that RockSim accounts for this in the simulations. Does it account for the fact that black powder burns in a different direction than composite? Yes and no. Yes, in the fact that RockSim could show this, but no, it does not currently show it. And then the reason is that information is stored with the rocket motor file. And we don't make motor files here at Apogee. They're made by other users, and how those users make those motor files can determine what it would look like. So let's dig in a little deeper here. So with RockSim is a program called Engine Edit. Okay, so this comes bundled with RockSim, and it gets loaded with RockSim, but it's a separate application. And it looks like this. And let's go File, Open. Let's see if it's pointing in the right direction. And it is. Okay. So right now I'm looking at, let's find, here's an Aerotech. Let's sort this by name. Look at all these Aerotech motors. Let's go with it. Okay, so an Aerotech E20 is a composite motor, and composite motors burn from the inside out. Let me show you a simulation. So on our website, go to How-To and Guides, and then come down here to Rocketry How-To and Technical Information, and come over here to How Composite Rocket Engines Work. So click on that, and this is a little animation that shows how composite motors burn. So if you look at it, if we cut a composite motor in half, we have, this is our propellant, and it has a core right down the middle. And you'll put the igniter in the core, and it burns from the inside out. Plus, it burns from the surface on the back end and the front end. So it's going to burn on this surface and on that surface at the same time. So this is actually, it's called a Bates grain, which is the technical term for it. So that by the time it reaches out, the front and the back meet in the middle. And if it meets it directly in the middle at the same time it reaches the outside, it's called a Bates grain. And the advantage of that is you get a fairly flat thrust curve. So you don't get this huge spike. It's more flat and stable over the entire burn. And that's why people use them. So most composite motors are made that way because you don't want like super high thrust and you don't want super low thrust. You want something right in the middle. So if we click on the animation, you'll see the igniter goes in, clips attach, and we're going to ignite it. So electricity fires off the igniter. You click the button, and it's stalled. You didn't even see that. So let's back up. Let's back up one more. Okay. Okay, so it's burning from the inside, and you see the front and the back also move in. So how this affects the center of gravity? So basically, the center of gravity doesn't move. While the motor is getting lighter, it doesn't get lighter on a black powder motor. It burns from the back to the front. So actually, the center of gravity is shifting a little bit. And it's shifting towards the front of the motor. At the same time, it's getting lighter, so the whole center of gravity of the rocket is actually moving back. so the whole center of gravity is moving forward because the back end of the rocket's getting lighter. So you got the center of gravity of the motor, and you got the center of gravity of the rocket, and they're kind of moving, together in the same direction. They're both going forward. So it's not a big deal. And to be honest, you're probably not going to notice it that much. But if you wanted to change it, you would go into Engine Edit. So here's an E20. And then you go here to the CG curve. If you click on the CG curve, right now, our center of gravity over the entire burn time, so the burn time of this one, or the burn time is 1.76 seconds. So the burn time over the total 1.76 seconds stays at this 3-inch line. If you wanted to change it, you uncheck this button right here, and then each of these points right here is a point on the thrust curve. So if I click this one right here, oops, that one moved. Why did that one move? So yeah, I could move the I could change the coefficient or the CG location. So it starts at 3 inches, and then it shifts all the way to the front, and then it comes back to 3 inches. Figuring out this CG curve of the motor is beyond my mathematical abilities. I'm sure there's computer programs that do this. Trying to think of something that might, I don't know what it is, but it is possible. But then you load this into RockSim, and then you would see that CG curve. Where it is most critical is not in black powder or composite motors, but it's more critical in hybrid rocket motors. So if I went to File, Open, and Hypertech motors are hybrid motors. I think the contrail also might be. So save my changes, no. So this motor is a hybrid motor, and it should say hybrid. And it's got a length of 21 inches long. And it's also got an oxidizer tank that's up front. So if you looked at, if you were in RockSim, you have the motor, the propellant, and then you have a separate tank that's even farther forward inside. It's usually all like one long, it looks like one long piece, but the center, the oxidizer tank is pretty far forward, and that oxidizer tank could actually be in front of the center of gravity. So when you're losing oxygen, or the oxidizer being in front of the center of gravity, it means that the center of gravity is actually going to shift backwards as it burns. And so hybrid motors, that's where you might want to think about having a center of gravity shift in the rocket motor file. Although, like I said, it's pretty hard to predict what it's going to be. I don't know. That's a good question for AI. It's smarter than I am. Yeah, so the question, Rick, is yes, you can have a thrust curve for the or a CG curve for the motor. RockSim does have the ability to do it, but you need the data in there, and I don't have the data. Wheelock says, how much is the Wheelock rocket going to cost at Apogee? Well, my guess, if we had to make this into a kit, it's pretty close to the size of the grappler. So if you go to the grappler, you can see it's 5843. So 2.6 inches in diameter. This one is 45 inches long. This one is 36. So, somewhere around that $55 to $58 range. If I had to, you're asking how I'd price it, that's how I'd price it. Okay. Action says, sir, my problem is that I understand CP, but I can't calculate it and their position, single and multi-stage rocket. Please clear it. Okay, so the center of pressure is, if you wanted to calculate it by hand, you need to use what's called the Barrowman equations. So where do you get the Barrowman equations? So you can, open up and you can search in a search engine and you can find the Barrowman equations. And here's the Barrowman equations, and you can see they're pretty healthy. So what you only do the Barrowman equations once in your life. You do it once to check things are working, and then you say, "Man, RockSim can do it so much faster than I can do it by plugging in numbers in a calculator." Because the Barrowman equation, it calculates the position of the center of pressure. Our software automatically does it, so you don't have to calculate it yourself. And in fact, there are some problems with the Barrowman equations. There's some limiting assumptions in those equations. And in RockSim, we took out those assumptions. So for example, one of the assumptions is the rocket has to be long. So if you try to make a short rocket, the Barrowman equations are going to break down. The other thing is the Barrowman equations only allow for fins that are either trapezoidal shaped or elliptical shaped. Now this is neither a trapezoid nor an ellipse. So the Barrowman equations could not do that shape, but RockSim can. We figured out a way to figure out how those affect the center of pressure. So the easiest way to see the center of pressure is just to change the shape or position of parts on the rocket. And the things that affect the center of pressure most are the fins is the greatest, and then the nose cone a little bit. The tube pretty much doesn't have any impact. So you can make this as long as you want, and the center of pressure won't change except for if the fins change with it. So if I go to the fins, edit the fins, and if I change the location, so you're looking at this red dot here, this is the center of pressure. And if I change the location just by sliding him, you can see that the center of pressure is moving with the location of the fins. And it's moving faster than the center of gravity. Now the center of gravity is moving also because the location on the rocket, the weight, is moving forward. But you can see that the center of pressure is moving a lot faster. And eventually, we can move that center of pressure ahead of the center of gravity. And when we do, you'll notice it right here, it says unstable. So this rocket now is unstable. And if we launch it like this, we just hit the launch button again, hit the flight profile, and it does a launch. And I peaked, and it says it only reached 81 feet. So basically what happens is it launched and then it went unstable and it's starting to just spin end over end and it doesn't know which way to go. So that's why you want to have the center of pressure always behind the center of gravity. And calculating it, you can do it. It takes a long time. I've done it once. And at that point you say, let the software do it. David H. says, can you step the fin tabs to show the tabs slotting into centering rings? No. So what he's saying is, if we go here to the fins, and I'm going to move the fins. I want to put it like spanning a ring right here at the back. So I'm going to move the location. oops, I went too far, right there. Say I wanted to put my fins right there, and I'm zooming in, and there should be a notch to go around that that centering ring. And his question is, can you use RockSim to do that? And the answer is no, because these are the only parameters I have to work with. I got a tab offset, so I could actually move it behind that centering ring, or I can move it in front. But I can move this one in front. You know, let's make it 0.125. So you can see I've moved it ahead of the ring, but now I don't have any other controls to start a new one back here. So how would you fix this problem? Well, let me move my tab length back. You would have to like print out your fin and click OK there. Then we go to print. Here's the print menu. And I want to print, I don't want to print any simulation information, so I'm going to uncheck that. I want to print rocket information, and I want a side view. I want a rocket drawing. I want a side view. And I want to show everything, and then click OK. And it brings up a print dialog, and I'm going to print it to a PDF, and I'll call it side view, and hit save. And go to my desktop. And where did it put it? Oh, it crashed. It didn't like that. Reopen. Yeah, so basically what I was going to say is create a side view of the rocket, and then, because you're going to need the side view anyway to cut it out, and then just figure it out. David H. says, one other thing, engines fail on wind conditions. Can RockSim also give safe wind conditions for an otherwise good engine? I've never seen engines fail on wind conditions. The wind should not affect the motor at all that cause it to fail. The wind can cause the rocket to go unstable, but that's not a failure of the engine. So if I'm missing something, let me know. Okay, any other questions? Let me know. There was a question last week, and I remembered it while we were talking about something else, and then I just forgot it again. But one of the questions I have for you is the question I asked earlier is, do you have a topic that you want me to do a build video on? I need a topic. It will so his question is, it will weathercock on a low impulse engine. And that's true. So can RockSim also give a safe wind condition? Okay, so let's open a rocket. Oops, I want rocket open. Where did I save that rocket? Did I save it on the desktop? Wheelox rocket. There we go. Okay, so if I make this rocket longer, I can make it weathercock. So let's do that. So rocket design, let's change the length of this rocket. I'm going to change the length. We can see that the fins were not set to, this is why you got to change the reference location. So my fins are referenced from the front of the tube instead of the back of the tube. And let's go to the fins, and we'll change those from the base of the rocket, and let's make it 0 inches. Okay. Okay, so now we took that rocket, we made it a lot longer. So now we're going to choose a low thrust motor. Let's go with an F15. 8-second delay. Click OK. Flight events, everything's going to stay the same. 60-inch launch rod, and we're going to do a flight profile. And I'm hoping that this one will weathercock into the wind. If it does, I don't think it is. It didn't. My wind might not be strong enough because it looked almost like going straight up. That was a really pretty flight. So let's change the wind. Didn't go as high. Starting state. Let's change the launch conditions. Oh, I had 0 wind. Let's make it like a 15-mile-an-hour wind. Flight profile. Okay, same thing. And launch it. I don't think the wind is showing up because the wind is not moving. The wind should be blowing stronger here. So what's going on? Some variability. Let's make it a constant speed. And it says no wind. Custom wind. Flight profile. Oh, the things I do to get some wind. All right, so now I moved the rocket. So it's going to weathercock this time because RockSim tries to figure out how far it's going to go. And before it was here, now it's in the middle of the screen. So it's going to tell me it's going to go into the wind. All right, so it's weathercocking into the wind. It's going up. And there it goes. And yeah. So now this rocket, this trajectory, oops, I hit cancel. Let's see that again. This trajectory is not a good trajectory. I want to see the apogee point, which is probably this one right here, inside of this cone. So the question that, who was it? Was it, I thought it was David. Where'd that go? There's a whole bunch of more comments. His question is, can RockSim also give safe wind conditions for an otherwise good engine? So the question is, can RockSim tell me what the maximum wind is for that engine to keep the apogee point inside of the cone? Trying to think if I can automate that somehow. That would be pretty interesting, is to automate that process. And then tell me what's the maximum wind for that particular motor. That's a pretty good question. And, you know, I can do it manually. So right now we have a 15-mile-an-hour wind. So let's go back and change that to, you know, a 6-mile-an-hour wind. And so this would be the process, is to change the wind speed, click on flight profile, and then see if the apogee point stays inside the cone. So at 6 miles an hour, yes, the apogee point, the highest point, so this point is lower than this one, so the apogee point here is okay. So somewhere between 6 and 15, or maybe, was it 8, worked good. Hit flight profile again. The only thing that changes is the wind. Okay, so at 8 miles an hour, we're outside of the cone. So at this particular case, so somewhere between 6 and 8 is going to be that the maximum wind that this rocket, I would say, could handle. But here's the thing: if I change the launch angle, now I can manipulate that point. So if I angle the rocket with the wind, I bet you I can get it inside the cone. So we'll go prepare for launch. So the starting state, I'm going to angle the launch rod. And let's give it like 5 degrees. And then hit flight profile. And then launch it again. So we had angled it this way for 5 degrees. And the only thing that's changed, we still have 8 mile an hour wind. And now it's okay. So it's a very hard question to answer and to automate, because we're assuming that we're only launching straight up and we're trying to keep the rocket going straight up, but we can angle the launch rod and affect the trajectory. So it's a very, very hard question. Oh, that was the question. The 3 fins versus the 6 fins. Thank you, Curtis. Curtis, maybe, did he ask that question last week? Johan says, hey, you missed me building a rocket launcher bicycle cart. Is Apogee going to sell the Wheelox rocket? That's probably no. Johan says, oh no, I'm suddenly fan number 3. And Johan says, hey, both number 1. They're fighting over who's the number 1 fan. Thank you. I appreciate that. MOB Rocket says, idea for a build video. Fillet making techniques combined with the best material, especially since no more rocket epoxy for each type of rocket powered. So making fin fillets, that's a good question. Do we have a video on that or something similar? Construction videos, go to all videos, and now I'm looking for fin fillets. So I'm going to do a find on this page. I'm going to type in fillet. And it's used 37 times. So here is a simple glue fillet. So if you're just starting out in rocketry, this is the basic one. It's not the best one, but it's a good one when you don't have other materials. This is particular to the TTV. So these 2 videos are about fin fillets in general, why you want to use them, how to make them. So I would start with this one right here. This is video number 385. But I'm sure it shows the rocket epoxy, and like he said, there is no longer rocket epoxy. We haven't been able to get it since before COVID. It's just they just don't want to make it anymore. So the best thing that we've found that's most equivalent to it is called the G-Flex. G-Flex. This stuff right here. It's a very thick epoxy. It's a nice epoxy for fin fillets because it doesn't run. So in that way, it's very much like the rock epoxy used to be. The big difference is the color, and this one actually has a little bit of an advantage. It's actually got a little bit of rubber inside the epoxy, which gives it a little bit of flex, and that's where the name comes from, G-Flex. So it's a little bit more flexible. So if your rocket lands on the ground, the fin can flex a little bit without breaking a fin fillet. That's kind of why we like this. When you first use it, you after it's cured, it still feels a little bit tacky. And that had me concerned that you wouldn't be able to sand it. Because if you ever try to sand anything that's tacky, it just doesn't work. But this stuff actually, the tacky is just on the outer surface, and as soon as you start sanding it, it goes away. So it does sand, and it sands as good as any other epoxy. So in that way, I like it a lot. So it's got some benefits. So now the question is, how do you apply it? And my newest technique is going to be shown. I just did a video, and it won't come out until I'm gone at the World Space Modeling Championships. And I can't remember. I think it's in 2 videos from now. And it's a long video. It's 31 minutes long because I just finished it up this week. So the next video, which is in 2 weeks, because we just had one, will be about redundancy in electronics. And then it's going to be about, it's a different, I won't tell you the topic, but in that video, I did through the wall fins, and I needed to put fillets on. And so I showed the technique of putting fin fillets on. So that it's coming, but it won't be named anything to do with fillets because the video is not about the fillets. It's just I happen to make fillets in the video. Schmerp says West Systems 610 is pretty easy to use and it sands well. This stuff right here, this G-Flex, is also made by West Systems. So it's I'm sure it's, I don't know why they have so many different varieties. So 610 may be pretty good. I've used the liquid West Systems. I usually use the fast hardener. I think it's hardener. They comes with a basic resin, and then there's different hardeners. There's fast for hardener and slow hardener. And I usually use the fast just because I'm impatient. Sometimes using the fast is not the thing to do. I was actually making fin fillets on a small rocket using the fast hardener, and it was hardening too fast, and I couldn't get the fillets on fast enough. So next week, I will still be here. So we'll go one more week, and then the following week, which I think is the 14th, we'll be off. So on the 8th, we'll be here, but on the 14th, we'll not be here. Or is it the 7th? The 7th, we'll be here, and the 14th, we won't. So get your questions ready. Schmerp says, I'll be your #1 fan for life if you help me with my high-power 2-stage simulation. Oh, that's easy. You just run the simulation like it's a low-power 2-stage simulation. But if you need help in the meantime, we don't have enough time today. But if you go to the home page, you're not looking at my screen. Go to the home page, come down here to the RockSim free training. And this is all the previous videos. And you do a find on this page. So you do a Control F on the Windows computer, Command F on the Macintosh, and do 2-stage. We've only talked about it one time. Let's type in 2-stage this way. Changing a 2-stage design to a single stage. The process of determining the delay motor between 2-stage rocket. Oh, come on. Loading motors into, okay, that's like episode number 9. That will be kind of like setting up a 2-stage rocket. So we could talk about it next week. We can also talk about the 3 fins versus 6 fins. I swear I was going to talk about this week, but I forgot. So we'll try to do that one next week as well. So we'll have 2 topics. Remind me what they are, though, right at the beginning so I don't forget them. Okay. I think that's it. I think we've got enough. We've talked about enough stuff. I know we could go for forever, but we got to go. So I'll give you a count. So I'm launching tomorrow. So if you're launching tomorrow, I hope you have a great launch. We're going to be launching some more rockets to play with. We're going to be doing some test flights for my daughter's competition rockets. It's going to be fun. Looking forward to it. The weather is supposed to be nice in the morning, and then in the afternoon it's supposed to get windy. So we'll fly early, fly often. So thank you for being here. And I'll give you a countdown and we'll get out of here. So in 5, 4, 3,